Hello and welcome to The Road to Autonomy. I'm your host, Grayson Brulte. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to The Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to welcome Dr. Peter Vaughan Schmidt, CEO of Torc Robotics. Peter, welcome to the podcast.
Yeah, hello. Glad to be here.
I'm excited to have you here because Torc is scaling, but more importantly, Torc is a business. When I read the press release that you were joining Torc and all your public statements, it really seemed that you were brought on to make Torc into a viable, sustainable business. Am I right in that assumption?
Oh, yeah, you're spot on. That's my mission. That's why I'm here. I've done it once before in my life, launching Daimler Trucks Global World Engine Program, which was a super great experience, I think, and left also a lot of impact in the trucking industry. But now being able to do this with Torc, for Torcs, bringing Torc to the next level, using this great tech foundation that this great people build, and really now developing this into a product that can be launched, that customers love, that creates a business. That's the mission why I'm here, and I'm so excited about this.
You're on this mission, but I want to go back before we talk about the mission. Last November, you were very kind and you hosted me in Albuquerque and I went for a ride in one of your trucks. And there was a common thing that I noticed meeting the Torquers, a sense of pride, a sense of respect, a sense of safety, and an overall really great culture. Is that culture one of the main reasons why you decided to join as CEO? And will that culture allow Torc to scale and to become a business?
Yes, but this culture was there since many, many years. And I think that's one of the great things that also Michael Fleming, the founder, really achieved. And that was the main reason why Daimler Trucks back then also acquired maturity on Torc Robotics. And I was the driving person behind this. Of course, it was the technology. Of course, it was the strategic fit. But most importantly, it was really the cultural fit. If there's no cultural fit, then usually an acquisition is not successful. Yeah? And this was really from the beginning, we had the feeling within Torc that these are just people we like to work with. And for me, then it was even cooler now being part of this. Yeah? While the last 3 years I was working hand in hand with Torc Robotics, now being part of Torc Robotics is even cooler. And we really want to maintain this culture and even drive it forward.
You're definitely driving it forward. Was it the technology in the culture that you saw that led Daimler to making the majority stake in 2019? Or did you see a path to commercialization? Or what was that overall driving factor that you said, okay, we're going to acquire Torc because we saw X?
First of all, autonomous is a really, really difficult problem to solve. It was just cool to have some experts that have done it since now 17 years. And a fully functional team, which is somewhat, let's say, the core or the nucleus that you could grow. Merge with a lot of automotive experience, which is there on the Daimler side, and create something even more powerful. Let's say the perfect blend out of this autonomous robotic startup plus some automotive experience. But then also the humbleness, the experience with customers, the culture that you were mentioning, the spirit within the company supporting each other, always challenging each other, driving for the best solution. But then also being humble when it comes to customers, listening to them, helping them to then take their concerns serious, using it to improve your product over and over again. These were the main reasons for it.
The thing I always liked about what Andrew and Mike did, they bootstrapped a company. Andrew would tell stories where we don't know if we're going to keep the lights on next week, but they never took any venture capital, any outside funding. They just focused on building a business, building revenue. Did that play a part of this? Okay, we've got a really gritty founders that are willing to go to the next level, that understand the importance of revenue for having to make payroll, to make the bills, so the utilities, so the lights go on and the employees can show up next week. Did that play a part of it?
We really liked the fact that the founders year over year reinvested everything into the company. I mean, you could, from today's perspective, you could say, how crazy is that? Yeah. Why not buying big boats and airplanes and things like that, but really reinvesting all the money to further grow the company. And also, I think a lot of responsibility, social responsibility also with your employees, with the families of the employees, but overall the spirit, the commitment that we felt, that was really convincing. And most people, by the way, after the acquisition also stayed with Torc. Yeah? I think we might have lost a handful, but 90% plus really stayed with us, are still part of the mission. We're building our Torc to a really big company in the meanwhile, with 5 locations globally, a couple of hundred people now. Yeah, it worked out very well.
It was fun. We were having dinner in Albuquerque one night, and there were several employees, and they were bragging, I'm a lower employee number than you. How are you here before me? It was this funny back and forth of who could have the lower employee number. And that plays into the culture, because from what I saw from meeting and speaking with several of the individuals that work at Torc, they're very proud to be there for a long time. They want to stay for the long haul because they believe in the mission of Torc. Well, you believe in the mission with Torc, you're here, you're building a business model, and then you have the great technologists that are building your autonomous driving stack. 2019 to 2023, that's a long time in autonomy world. It's practically a century. How has the technology evolved from 2019 to today?
I think we are currently really at an inflection point where many foundational technologies reach a level which is just needed. Simple things like there is an autonomous ready truck with all the redundancy. Wasn't there 2019. Sensors, especially for our mission trucking, you really need to sensors that have ultra long range, that can look out far or look behind far and have great detection rates there. So those sensors were not existing in the past. In the year 24/5, they will be more or less standard in level 3 highway pilot systems. So the sensors are there, so to say, the eyes of an autonomous system. Also, the brains will be there. Just if you see the development of the computer chips, now with the latest generations, you finally have the computing power that is really needed to run your neural networks, AI, machine learning, robotics, whatever you do. But just you need an immense computing power, so to say, the brain of your autonomous system. There are a lot of really things, a lot of also, let's say, the know-how. What can you do with AI machine learning? But maybe also what can't you do? I think it's just finding out this perfect mix or blend, where to apply robotics, where to apply AI machine learning. I think a lot of foundational work has been done and is now ready to really launch a product. That is the big change. In 2019, there was maybe a little bit too much optimism or hype. We back then always said autonomy will be at scale within this decade by 2030, and it might start mid of the decade. So when we made that statement, some people were laughing on us, dinosaurs. But I think it seems to be a pretty accurate prediction of what is happening here. And now we are super optimistic and even bullish on what we announced back then, because we really believe that we have a plan to make it reality. And a little bit this gloom and doom of autonomy for us is hard to understand because we were never part of the hype. But now we really see that the true product development on cycles that we had seen coming, and we're executing along this. So that's why we are positive about our path to a product.
I always respected Torc because you never entered the hype machine. Never went into we're going to do this tomorrow. Oh, don't worry. We're going to go drive her out tomorrow. We're going to do this tomorrow. You were very calm and even keeled. And speaking to Andrew quite a bit, you built a product and you focused on building a product and keeping your heads down. And when you were ready to surface, you surface. And that's what you're doing now. And you mentioned the redundancy. Daimler's developing the autonomous truck platform. It's got 1,500 new and unique requirements based on the Freightliner Cascadia. That's really impressive. I repeat, 1,500 new and unique requirements based on the Freightliner Cascadia. Will those trucks eventually come to Torc? Will you start building on those trucks, testing on those trucks? And what is the advantage of having a 1,500-point redundant system?
It's the specs. It's not 1,500 components are redundant here. But what I really liked about our partner Freightliner, that they're thinking this redundancy really to an end, yeah. I mean, there's some obvious redundancies if there is no driver anymore. Let's say if the steering support fails, today the driver would apply more muscle power. Tomorrow you need a second electric motor to do the job. Same with braking. But it's also about hearing noises or smelling something. So there's a lot of redundancies that you need to build in. Building out this redundancy in itself is a huge technical challenge. But then the next question is, to what level? So should it be just good enough to bring the truck to a stop? Is that something safe? And Freightliner said, no. You could define it as safe and some kind of redundancy, but they really pushed it one level further. And they said, usually it takes up to 10 minutes to reach a safe harbor because it's not safe to, let's say, stop in a tunnel. or on a bridge or on a railway crossing. Yeah? You really want to reach a safe harbor. And then they even doubled it so that the system is able to run something like 20 minutes and still then can send signals for at least 2 hours. I'm stranded. I need help. This is my problem. And that is, I think, the kind of redundancy which is really needed. And I really love the engineering rigor by Freightliner that went into the chassis, and Torc also contributed a lot of specs to it.
The Freightliner Cascadia, it's a comfortable truck to ride in. It's a very comfortable truck. Your Daimler's building in the redundancy. Torc is testing in Albuquerque. It's an interesting place. I learned about the mattresses on the bed. You have the Albuquerque winds. But one thing that's not talked a lot about in autonomous trucking or even autonomy in general is elevation changes. I want to highlight something because Albuquerque to Taos, where you currently test, the elevation change is 2,409 feet. That's a large elevation change. It has impact on the engine brakes, your traditional air brakes. What is testing in that rigorous environment with these winds, beds, and elevation changes doing to improve the Torc driver?
You have really done your research. But that was the key reason why we went there in a really pretty close vicinity. You have it all. You have dense traffic, you have the desert, you have the elevation. Usually you have a lot of heat and summer, but there's also there's rain, there's snow. We just had a lot of snow in Albuquerque recently. So it's just cool to have all of this in our testing facility. And then we thought if you can do Albuquerque, you can do really most cities, most interstates. I think it's really, and you want to expose your autonomous system to challenging conditions, yeah. It doesn't help too much if your system can run in an empty desert road without winds and sunshine, yeah. But you really need the challenge of dense urban traffic, of elevation, of strong winds. For us, Albuquerque is a perfect testing field. And we get wonderful support by the city, by authorities. It's also, despite from, let's say, the technological aspects of testing, it's also for us a really nice environment to test in. And I personally like Albuquerque.
And then you have the Hot Air Balloon Festival every year. Have you had to deal with a hot air balloon? I went one year and the hot air balloons landed in some interesting places, and we took my daughter, we got to get the photograph in front of the hot air balloon, and we're chasing it. It lands in a field. One landed on a dirt road. Have you had the encounter with a truck, the hot air balloon lands in the middle and the truck had to have that edge case yet?
No, that's an edge case we are still looking for. But we had a lot of weird edge cases, like tumble wheels, all sorts of, letters or fridges on the highway, or got even struck by a lightning. We had a lot of edge cases, believe me.
Did I hear that correctly? A Torc autonomous truck was struck by lightning once?
Yeah, that happens. If you drive, and it can happen to any truck.
What happens in that scenario from a safety aspect? Does the truck just pull over, or what happens? That's an edge case never been discussed before.
I mean, it's a Faraday cage. It happens to truckers and car drivers. Now, all the time might be wrong, but if you consider the millions of cars out there, it really happens all the time. It's a Faraday cage. You pull over, and then with autonomy, you go safe. You take it out of business because you never know if something happened to the computer or the cable. Yeah. You would continue to drive. Yeah? You would check your lights and things like that, and then continue your mission.
That's really smart. And then in the dispatch center that you were so kind to show me, they get an alert, say truck A was struck by lightning, and they know to quote unquote take it offline. Is there some sort of communication system that goes back to headquarters?
Yeah. So the mission control always knows what's going on with our trucks, but even more what's going on with our fleets. They really know. You see trucks are running in testing in Albuquerque. You see trucks running on I-81 in Blacksburg. You see trucks in various proving grounds, for example, in Madras, close to Portland. You see all of them in mission control. You can zoom in. You can see, are they in manual mode? Are they in autonomous mode? You can draw all parameters. You can click on the cameras and just see what is the driver seeing, what is the autonomous system seeing. You get all error messages if there are any. That's what a good mission control should do. Yeah? It's monitoring one truck and the entire fleet at the same time, and it's able to communicate also.
It's really smart because I believe that as you look to build trust with your partners, your shippers, the carriers, and you have a very public partnership with Schneider, that will help to build trust so that the Schneider family can see, okay, Torc is taking responsibility. They're fully monitoring those trucks. I want to get back to the challenging environments here because you're testing on closed course, you're testing in Blacksburg, you're testing in Albuquerque, and you've recently expanded into Arizona. Arizona is known with a very famous company that tests on wide streets with really no pedestrians for the most part. But you said, we're going to expand to Arizona. We're not going to do it let's say, the Chandler way. We're going to do it the Torc way. We're going to go to extremes and we're going to push our trucks. We talked about elevation earlier, and I'm really curious. I did elevation research, so here comes another one, Peter. Kingman to Flagstaff is 4,019 feet elevation change. You've mastered Albuquerque to Taos at 2,409 feet. Eventually, will you master Kingman to Flagstaff in 4,019 feet elevation change?
Our autonomous trucks drive from Albuquerque down to Phoenix by Flagstaff. At least this area is part of our testing in the meanwhile, yeah. And I think elevation in the end, it's not so much the absolute height. It's really the elevation change, and it's then about the perfect use of your engine brake, more or less, so that your standard brakes do not overheat. And that's the key reason why we really want to change in such extreme elevation profiles. It's not only that it's a safety topic, but also, by the way, a maintenance topic. You also want to use the engine brake at the moment. It's really interesting to see how intelligently the system picks all, I think, 3 stages of the engine brake and smoothly runs through them. It's really impressive, like the best drivers out there.
It is like the best drivers. I was very fortunate. Several summers when I was growing up, my grandfather would take me out to Montana, Wyoming, and we'd spend the summers traveling around the West. And then you're a kid and you look out the window, you're not driving, you see interesting things. And one thing I never forgot, and I still to this day, runaway truck. We're going down the hill and they have this special thing built with all the gravel and the sand and eventually the water. You can't have that with an autonomous truck. You're sitting here, you're solving for a problem that I remember as a kid 20 years ago. Do you feel that elevation changes are one of your main competitive advantages? Because speaking to your colleagues in the industry, there's not a lot of discussion around elevations, but here I'm a kid. I remember the runaway truck stops.
Mm-hmm. I do not have the insights on what our competitors do and if they have it as part of their development pipeline. I'm sure they have. But for us, it was just important. Might be also the background of 17 years of doing business, also in mines and things like that. And of course, with Daimler as a key investor in Torc, it was an important topic for us to solve it right from the beginning. Yeah, paranoid, and not also about safety and solving a technical problem, but also down the road on things that are important to fleets, which is maintenance, operations costs, yeah, and fuel consumption. And especially also elevation it might be a huge, if you do it right or wrong with engine brake use, it's also a big maintenance topic. But if you also coast elevation perfectly, by the way, it's also a huge fuel economy topic. Yeah? So that's why elevation is important to us. Down the road, when we talk about a product, a scalable product, it will be about reliability, and then it will be about cost per mile. And today, fuel economy is important. Tomorrow, it will be important. Yeah? Today, maintenance is important. Tomorrow, it will be important. All the things you shouldn't forget about it. Just because it's autonomy, it's not gone. It will be as important as in the past. Yeah?
It's a very valid point. I was watching Bloomberg this morning. They were talking about the oil markets, and there were several analysts of some of the largest international banks, and they were talking about the price of West Texas Intermediate crude is going to go over $100 a barrel. So obviously, the fuel consumption will become a very large topic again, potentially this summer, or will continue to be. How good of a job does the Torc driver do in optimizing fuel consumption? Are there metrics where when the Torc driver is driving autonomously, it can lower fuel consumption by X? Are there metrics that you're working towards?
It's not the key driver of optimization currently. We definitely see a huge potential there. Let's say just by simple facts, the Torc driver will drive very homogeneously because it will never be critical in hours of service and things like that. So you can even downspeed, but you also don't need to take a rest to have a nap or to eat something. Yeah? If you stop a truck and restart it again, this all costs fuel. Yeah? An autonomous truck will just stop once when he completes the mission. So there are a lot of things where an autonomous truck has the possibility to really reduce the fuel consumption. Just more or less, I think the key driver is less speed and then a very homogeneous driving style throughout the journey, which in principle, of course, also humans could do. But it's just human nature. You usually don't do over 8 hours, and especially not if you are close to running out of your hours. Yeah.
Yeah. The one thing I noticed when you were very kind to put me in the truck, and I summed this up in a tweet after, the truck was calm, the truck was polite. There was a gentleman on a motorcycle that's zooming by, and the truck very so gently moved over to the right to allow the gentleman to lane split. I didn't even notice that the Torc driver was very polite, very calm. I didn't know it was making a lane change. I couldn't feel it until they point out to the screen to me, look, we're making a lane change. How are you developing such a calm, polite driver?
That's a good question. I think key of this are definitely our safety drivers and safety engineers. And you might have experienced that, when they are in the truck and there is such a maneuver, then usually the driver or safety engineer says, wow, nice job. And then the safety engineer documents, this was a really nice, polite, whatever, courtesy maneuver, lane change. Or they also say, it worked, but it wasn't great. Yeah, take this situation, give it back to the engineer so that they do better next time. I think this is the key driver behind this. A lot of those maneuvers we call courtesy maneuvers. Yeah? I didn't hear this before, but now my engineers told me. And this is a really key optimization part, especially also at ramps. It's super important to execute this courtesy maneuvers. It's just part of the development optimization process here in the behaviors and in the planning.
It's a behavior that's going to build trust with elected officials. It's a behavior that's going to build trust with the public when they know that mom's taking the kids to a soccer game down the highway, that the Torc truck's calm and polite. You feel safe. You don't have to worry about, is this person over hours or they have a mental issue. Your truck is going to be very complex. I think you're going to help build public trust there. From a technological aspect, what role did Daimler Engineering play in this? Are they working hand in hand with the Torc engineers to fully optimize the Cascadians to perform at peak performance?
Yeah, let's say in the core autonomy stack, it's mainly Torc know-how and Torcers who optimize it. For example, this courtesy maneuvers with a lot of input. Where Daimler engineers come to play a lot is really then in the interface with the truck. Autonomous trucking, it's see, think, act. Yeah? See, it's a perception piece where sensors perceive the environment. Think is then the brain. I want to do a courtesy maneuver, but then comes the act part. And here, I think in technical terms, we then call it motion control and things like that. Daimler engineers come into play and translate all this electric signal into, again, this smooth driving also comes from a perfect motion control and perfect integration into the truck. And here, a lot of Daimler engineers help do it or brought the know-how in. And then, of course, also consulting how to use an engine brake in just optimal manner and things like that. So being part of the bigger Daimler family without any IP barriers makes it just so much easier to optimize, let's say, across the lanes of demarcation, so to say. It's not so much I'm optimizing my part, I'm throwing over the fence, and then Daimler Trucks is optimizing their part and vice versa. This optimizing without IP barriers, I think, is one of the key reasons why you have such a smooth ride and such a nice experience in the truck.
You have the nice experience. You have the public trust. Next comes commercialization. It seems that you're well on the path to commercialization and commercializing the Torc driver. How do you first see Torc commercializing the product?
I think the business model will be pretty straightforward. The fleet will buy a truck from Freightliner, and it's completely outfitted with all the sensors, and it will really look nice, and it will be the best quality you could dream of, manufactured by Freightliner in the quality levels that you are used to. And the software mission control will come from Torc. Then how the exact go-to-market strategy in terms of pricing, is it a subscription or by mile? I personally tend more to subscription models, but all of this we will find out over time. And it might vary customer by customer. Yeah? Also today, there is more than just one model how customers can acquire a truck. You can buy it, you can rent it, you can lease it, you can finance it. So I'm pretty sure that also for the virtual driver piece, there will be different models how to commercialize. In the end, we really try to make it as easy for customers as possible to apply this new technology. And the way of paying will be one of it.
I'm going to throw out a competitive advantage. Daimler owns a bank. You've got access to financing. That's going to be a big competitive advantage there.
Yeah, maybe. You're one step ahead. Yeah.
I look at the models. Let's say you're going to develop a flexible model and you're going to allow your customers to choose model A, B, or C, depending on what makes economic sense and what makes sense for your board and your shareholders. Will these all be factory grade trucks built by Daimler with the Torc software? So if I'm company A and I want to buy it?
I think in the end, there will be some things that are carved in stone. I think one, it will be factory built. B, I think the customer will expect 1 year of payback. It's just natural law in trucking. Yeah, just because it's autonomous all of a sudden, they will still expect 1 year of payback at least. Yeah. So I think there are some things that are just carved in stone, what is needed to have a product out in the market.
You're still in the early days of developing your business model. And then as the industry as a whole is really shifting to the hub-to-hub freight transport model, there seems to be a lot of momentum in that model. What are your thoughts on that model? Does the hub-to-hub become the de facto standard? Perhaps it's quarter mile off a highway, half a mile off a highway where the truck will come to that depot or the hub, and then we'll get manually driven from there into a dense urban environment. What are your thoughts on that model?
I think it's a very valid model. It covers a lot of use cases. Quite often, the distribution centers or logistics centers are close to exits and interstates. Yeah? So I think with that model, you already reach a pretty large portion of today's real business. Yeah? Because if you drive from distribution center A to distribution center B, this hub-to-hub will complete, my conviction, the complete mission in one touch, so to say. There might be things where your final destination is really inner city San Francisco. Then you need to decouple the trailer and manually drive it. And then all of a sudden, this manual driving might be 4 hours, might be 8 hours. It must not be 10 minutes only. And then I think you can even think first and last mile much, much broader. But there are a lot of other things, all shuttles between two factories, connecting to Mexico, Laredo, intermodal. There are so many things that in the end, with this hub-to-hub technology, I think you are addressing a lot of markets. The entire parcel L2L market is more or less structured in that way. I think with that model, while it sounds like, it's only one model, you're at least addressing 6, 7, 8 segments of logistics.
Then there's drayage. When, in your opinion, do we see autonomous trucks start to go into the port for the consistent drayage routes?
There's some drayage operation. It always depends how complicated it is, let's say, the endpoint. The drayage in itself, I think, is a super attractive business model, but the endpoint might be a challenge. And that's really a case-by-case discussion. Engineers need to dig in and say, there are some drayage things that are pretty easy to drive, and there are some maybe 2035. Yeah. Don't underestimate the challenge that some of these locations can provide. And, for such locations, humans are the best option.
It's interesting because you're right, because that opens up the infrastructure debate. I've been talking to some folks at the Port of Charleston and the Port of Savannah, and they're looking at how do we accommodate autonomous trucks from an infrastructure standpoint? Can we build something to make it a designated lane, a designated area? It's like, that's very interesting, where the port ownerships are trying to do that. If a port ownership group said, okay, Peter, we're going to build a dedicated autonomous truck terminal, we're going to give you a dedicated lane to the highway. Does that become interesting if a company's going to step up and make the infrastructure investment for you to, quote unquote, potentially deploy or work with a Maersk or a global shipper in that port?
If a shipper carrier, you name it, port authority is willing to invest in infrastructure and doing dedicated lanes, arrival paths and things like that, that's very much helpful to convert, let's say, ultra complicated situations into manageable situations. And then we would, of course, be in favor of this. Yeah? Reality, in most situations, might be more, let's say, brownfield. We have pretty mixed operations of autonomous and manual-driven trucks. And, of course, we try to enable our autonomous trucks as much as possible to handle such, let's call it, mixed modes, but they have their limitations. Yeah? And then, especially in super complicated areas, dedicated infrastructure could help. But we don't want to be 100% dependent on this, because then that might also limit the application of the technology.
It definitely limits, but for the shippers on the maritime side, it's going to come down to optimization because the supply chain is complicated and is not talked about a lot, but you're well versed in the supply chain is changing. It's moving out of China. It's moving into Southeast Asia more. And the shipping routes are going to change. And we're seeing that data. It's going to be very interesting as the shipping routes change, as the global outsourcing changes. What do ports do to innovate? But we both know the common factor, no matter what happens, autonomous trucks are going to play a significant role in the future logistics. Autonomous trucks are going to help to shore up the supply chain. And my favorite thing is they're going to help to lower inflation. Peter, overall, how do you see autonomous trucks being deployed over the next decade? Will they start in the southeast on the I-10 and work their way to Jacksonville? Will they eventually work their way up to Oklahoma? How do you see them being deployed over the next decade?
Yeah, I think it's more the area that you described, I-10, I-40. So this, let's say, around this region, southern US, I think that will be the starting point. There's a lot of freight. There's strong economies, and the weather conditions are still favorable. That's just a perfect blend. A little bit better than where I originally come from, Europe. The countries with great weather usually have not so strong economy, and the countries with strong economy have, from an autonomy perspective, terrible weather conditions. That's very much different if you look I-40 south for an autonomous system. That's just a perfect blend. And by the way, 3,000 miles coast to coast, that's what we are also looking for in autonomy.
We're going to get there in the I-40's home to the Kingman to Flagstaff route at the 4,019-foot elevation change. So that's right there. And Torc's well prepared for that. And it'll be interesting to see when autonomous trucks are eventually rolled out throughout the EU. That's going to be very interesting to see. That's more of your background than mine. But Peter, in your opinion, what is the future of the autonomous trucking industry? And I have to ask you on the backside, when will autonomous trucks start to operate in the European Union?
In the European Union, that's a Generation 2 topic. I think it will start in US for multiple reasons. I mean, it's just all the talent that sits there to develop the technology, just the sheer size. What you need in autonomy is really a big country under one legislation. US coast to coast, 3,000 miles, more or less one legislation. This is super helpful combined with a strong economy. So there's a lot of freight, there's a lot of demand, there's driver shortage. I mean, all of this comes together and with the American innovation spirit. Yeah. So I think Europe, 3,000 miles, you start in Portugal, you end deep in Russia, and you're crossing 10 borders, not all of them safe. So it's really a second generation topic. First generation is US, and we might even see countries like, Australia or Canada before we see Europe. Let's find out. The future starts in US.
The future does start in the U.S. We're very proud. Torc is a U.S. company. We're very proud to have you as the CEO that's working on commercializing it. I can't wait for the day that trucks are running coast to coast, fully autonomous. And as we look to wrap up this insightful conversation, Peter, what would you like our listeners to take away with them today?
I think Torc Robotics, first of all, we take safety really serious. All we are doing comes with the safety first moment. So while we are super keen about the technology and all the positive things it could do for society and for carriers and customers, it's all about safety first. And I think we are a really good player in autonomy, and we are just here to solve these problems for our customers, the carriers. I think to the benefit of all. Torc is a great company, by the way. This you also should remember.
Torc is a great company with a great culture that takes safety seriously. Torc is developing the future of autonomy. The future is bright. The future is autonomous. The future is Torc. Peter, thank you so much for coming on the road to autonomy today.
Yeah, thank you for this wonderful opportunity to speaking to your listeners.
Thank you. Thank you for listening to the Road to Autonomy podcast. If you've enjoyed listening, please rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter @Road to Autonomy or email podcast@brulteco.com. The Road to Autonomy is produced by Brulte & Company. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect the views and opinions of Brulte & Company. The content discussed in this podcast is for informational purposes only and should not be taken as legal, tax, investment, or business advice.